can get started. Oh, that's one coming in. I have to say I'm amazed by the number of people attending an Azure session. Usually it's about between 2 to 12. I was in a conference in the US 2 years ago. 900 people showed up for the conference, had 2 Azure sessions, 12 people came to the first one, 11 people came to the second one. Same people. Okay, but that's nice. How many of you, by the way, are actively using Azure for your applications? Okay, testing it, trying to figure out if it works well for your applications. Okay, how many people here never used Azure before? Ooh, okay. Okay. So I have to say that unlike most of my sessions on Azure, this is not an introduction level session of Azure. I'm not going to talk about what Azure is. I'm not going to show Azure services. Actually, I'm not even going to open the management portal. What I'm going to talk about in this session is the experience that we had in my company from assisting other companies and enterprises that use Azure to solve issues that they had, to architect the application to the cloud, and basically stuff that we learned of that we think everyone should know about Azure, especially, of course, those that are actually using Azure. So how many of you have been to Nuno's sessions on Tuesday about architecting for the cloud? We had a session on Tuesday about it. No one? Wow. Okay. So either he had a whole bunch of other people or he spoke to himself. Interesting. Okay. So first, let me introduce myself. My name is Ido Flatow. This strange accent is because I'm from Israel. I'm not a native English speaker, so I hope I won't make too many grammar mistakes. I'm a senior architect at an Israeli consulting company called Sela Group. We do a lot of consulting in the Microsoft field, so it's both development with .NET, server mainly, that's my specialty, server and web. I'm also an author of several of Microsoft official courses. So if you did one of the Microsoft courses in the past couple of years, it might be a course that I authored or helped to check out. I'm not an Azure MVP. I'm an ASP.NET MVP, but I do a lot of Azure consulting in Israel and abroad, training Azure courses abroad, and I'm officially, as it appears, I got an email a couple of days ago that I'm the technical support specialist of Azure in Israel. I got it as a side note saying, we have to increase the consumption of Azure in Israel, please help. I asked them, well, I'm not working for Microsoft, what do you want me to do? And they said, well, it says here you're the Azure TSS for Israel. And I'm like, okay, can you just explain what TSS stands for? And that's how I knew I was an Azure TSS. So in this session, what we're going to talk about in the next 90 minutes, I hope it will be 90 minutes. Last time I tested out this session, it took me 2 hours. So I might talk faster. No, that's okay. It should take about 90 minutes. We're going to talk about, first of all, how much Azure costs, and the things that you know, and the things that you might not know about the cost of Azure. We're going to talk about how Azure stuff really works, and the things that you might know of how they work in Azure and how they actually work. And of course, throughout this session, I'll give you some examples from customers that I dealt with, and stuff that we thought that worked in a specific way in Azure, and then realized it works in a totally different way, which of course affected our architecture, caused us to move back from platform as a service to infrastructure as a service, and that sort of stuff. I'm going to talk a bit about lessons that we learned about architecting for the cloud and working with the cloud. I'm not going to discuss how to architect for the cloud. That's Nuno's session that he had on Tuesday, so if you missed that, there should be a recording on the website, I guess, in a couple of days. I'm going to talk about the Azure preview features. For example, just 2 days ago, there was a new announcement about an Azure preview feature called App Services or something like that. Anyone caught that announcement? No? Okay, I didn't have the chance, I worked on this session. And I'm going to also point out some of the tools that we use in Azure, tools that I use myself, tools that I saw IT and developers use for Azure, and I thought that, whoa, those are great tools. I want to show those tools to other people. So there won't be any screenshots, but there will be a lot of tool names and links. And by the way, throughout these sessions, there are plenty of links to get additional information, to hear about how Azure works, to read articles. A lot of links. You don't have to pull your camera every time. There's a link at the end of the session to where you can get the slides from. Okay, so just wait till the end. But if you have to rush, just, maybe I'll give you my email just in case you have to rush out and, come on, Mac, come on. Not working. How do you open Notepad on a Mac? Just tweet me. It's Ido Flatow. Okay. Ido Flatow. Just tweet me if you need any other information you have to run, just in case it takes me 2 hours and you want to eat. Okay. Okay. So let's start to talk about Azure costs. First of all, how many people said they're using Azure, either for production, development? How many of you actually ever viewed your Azure bill instead of just getting that email saying, your Azure bill has been posted, you will be billed on the 5th of the next month? Usually, most of us, unless they see some deduction in our credit card, we ignore that email. We actually don't know how much money it costs us to manage our Azure resources and what exactly we're paying for. Has anyone ever downloaded that CSV file that contains all the billing information? No, right? Yeah? Only the beginning, yeah. Just to see that, yeah, we can see the information there, but then you just forget about it. There's another nice, I don't know if to say nice thing about Azure. How many people here know if the Azure subscription is an enterprise agreement subscription, an EA subscription? Anyone? No EA? Okay. Azure has 2 different types of subscriptions. The ones that you buy for yourself, for your company, the one that you just go online, fill the information, specify a credit card, and get billed. That's what is known as the pay-as-you-go subscription. For that one, you can go to the management portal, to the account portal, and watch the resources that you consume and how much they cost. There is another type of subscription, which is sold by resellers, Azure resellers, different companies that work with Microsoft. And that subscription has a bunch of discounts in it. That's the bottom line here. Don't forget discounts. If you're actually using Azure for about $1,200 to $1,500 per month, you're probably eligible for an EA subscription that can give you up to 30% discount, between 20 to 30%. So if you are using that, just write down EA subscription, check with my Microsoft representative, and check that afterwards. But the problem with that billing, for example, is that if you download the CSV file that shows you all of your resources, it only shows you how much you consume. It doesn't show you how much it costs, because Microsoft is saying, well, you have to check with your reseller how much it costs. So you have to download the CSV, send it to your reseller, and then wait for a couple of days to get back the CSV with the price. That's another problem with Azure billing that people don't notice. So what do we pay in Azure? First of all, a lot of us already know we pay for what we use. We pay mainly for instances. You have a virtual machine, you have a cloud service, you have a website. According to the size of that deployment, you pay. It can be, I don't know, $40 to $60. So I'm talking in dollars and not in pounds because I have a hard time calculating it in my head. It's about 1.5, right? So about $40 to $60 for a single core instance. So say you have a quad core machine, that will be about $160 to $200. If you're using the website, it might be a bit more. Depends if you're using the shared tier, the standard tier, the basic tier, that sort of stuff. But instances costs most of your bill. That's the major portion of your bill. In addition to that, you have, of course, the storage. If you have any content like blob storage, if you upload a lot of files to Azure, if you have a big database, you pay for that. Premium databases can go up to a couple of thousands of dollars, but all of that you probably know about because those are the major portions of your bill. And of course, you know that you also pay for bandwidth. So everything you send up to the cloud, everything you upload to the cloud, doesn't cost anything. That's called ingress data. But everything you pull from the cloud, if you have a web application and your customers are downloading, let's say, 1 gigabyte per day from your website, you're actually paying for that download. Okay? It's about a couple of cents per gigabyte per month. So if they're downloading 100 gigabytes, it will cost you about $5 a month. So if you are doing an online video library and people are downloading video files, well, consider that you're going to pay for that download. Okay? So that's the usual stuff that we know of, right? If you have a virtual machine, if you delete it during the month, you just pay for that period of time. So what are the things that you don't know about? Let's start with, for example, virtual machines. Virtual machines, you pay for the core, but virtual machines have virtual hard drives. Virtual hard drives are stored in storage. Storage costs money. So the virtual hard drive itself costs you money. Okay, it can be a couple of dollars per month. If you have, I don't know, a database that takes 10 terabytes of data, it will cost you probably a couple of $100 per month just to store those database files. So you should be aware of that. Transactions. You think of storage as only, you only pay for storing the data. No, you're actually paying for each request you send to that storage account. You want to get a file, you send an HTTP GET request, you pay for that GET request. You want to delete a file, you send an HTTP delete request, you pay for that delete request. Now, of course, you're not paying for each request, you're paying in a bulk of transactions. It's about a couple of cents per hundreds of thousands of transactions. But for example, if you check your blob storage every 25 milliseconds to find out if there is a new file in the storage, then you'll end up having a couple of thousands and tens of thousands of storage transactions per day, and then that sums up to several dollars per month. Okay? So those kinds of things just accumulate storage accounts, bandwidth. Even if you're doing, for example, monitoring. Who here ever turned on monitoring on a storage account or on their machines? You can actually go and turn on monitoring and logging on your storage account to get text logs that shows you exactly which client, which IP called your storage account and which file they asked for and how much time it took to respond with that file, to return that file to the client. All that information can be monitored and logged, and you're actually paying for that data to be stored. And that can sum up to a couple of megabytes per day if your storage account is really active. Now let me tell you a short story about monitoring, for example, and something that we learned by helping a customer with a very bad experience with Azure storage. So as I mentioned, you have the ability to monitor your storage accounts. You also have the ability to monitor your servers. Monitoring a server in Azure basically means that Azure just checks the CPU, the disk, the bandwidth of that server and stores statistical information so you can check up to 7 days ago what happened to that machine. How much CPU, average CPU it used, how much memory it had used, how much network and disk space, that sort of things. Now Azure, of course, calculates that information and stores that information in storage, usually in table storage. Okay? You can specify exactly which storage account to place that content in. Now, since we all know that we pay for data that we send between data centers, we'll probably choose a storage account in the same data center as our servers. Okay? If we have a virtual machine or a cloud service in the North European data center, which is just nearby in Dublin, we'll probably store the same storage account also in the same data center. Now, I had a customer who did just that, and at the end of the month, they found out they were billed for $6,000 just for fetching data from that storage account. But that storage account was just for monitoring. And $6,000 for pulling data out of the storage account for what it was egress data doesn't make much sense. So they checked, First of all, they noticed that they weren't using that storage account only for monitoring. Their application actually used that to create tables and to store data in those tables, but that wasn't that much of data. It was basically just session information about users. So it took they paid about $20, $30 a month for the session data, plus that $6,000 that suddenly they were billed for. So we started to look at it. Of course, the first thing that we did was to open a support ticket with Microsoft. The second thing that they did, the company, which wasn't good, they deleted the account. It's not good to delete stuff that you're billed for and you're trying to figure out why you're billed for, because that way Microsoft can't help you. They want to see logs, and you just deleted the storage account where those logs are being saved. So what we realized is the following, and that was with the help of Microsoft. When you do monitoring, that stuff is saved in the storage account that you provide. That's great. But there is some place in Azure that shows you the actual monitoring. Have you ever noticed that in the management portal you have those monitoring graphs? The management portal, the service itself of the management portal is stored in the US. It runs on a US data center. So for it to fetch that information, it needs to call into your storage account where you save the monitoring data. So there are actually calls being made from the US to the European data center to pull that data. And you pay for pulling that data. Now, that shouldn't have been a problem because it's just a few lines of numbers. But apparently there is some kind of a design flaw. What they do is that they first send a query to the table storage to get back the list of tables in that table storage. Now, when you have just one table in that table storage for monitoring, that's okay. But when you have about 500,000 tables in that table storage, because that customer decided that to save the session information, they will create a table per customer, per user. So they had a couple of 100,000. So just for the monitoring service to get the list of tables, it had to submit a couple of thousands of queries to the storage account. And all of that data coming out of the storage account every day cost them $6,000 at the end of the month. So first of all, just to get a good tip out of it, don't create hundreds of thousands of tables in a storage account. There is also a really good reason why not to do that. Try and open that storage account in any Azure storage account viewer, in Visual Studio, in Cloudberry Explorer, all those tools that show you your tables. You won't be able to even view that storage account because it has a lot of tables and it can't pull that list from the server. Okay, well, it actually took us 30 minutes to execute a PowerShell command to just get the list of tables so we can send it to Microsoft. Okay, so don't create tens of thousands of tables in your storage accounts. The second is check your billing. Okay, they by accident saw that because their CFO shouted out, "Why do I see $6,000 on my credit card instead of just $20?" Check your billing. It's surprising to find out what you see in there. Okay, you suddenly find out that you're paying $100 a month for virtual machines your developer created, deleted, but neglected to delete the hard drives. Okay, so how can you reduce your Azure costs? First of all, turn off your VMs. Now, of course, don't do that for production machines, unless you're only serving the European clients and you know they all go to sleep at midnight and wake up at 6 a.m. But there are a lot of machines in Azure that we use for dev and test. Okay, I have my own servers that I installed Visual Studio in and do stuff in the cloud. A lot of people use test machines to replicate their test environment in the cloud, or to have load agents as virtual machines in the cloud. Now, those machines usually are used while we're at work, and we can shut them down on day's end. So, first of all, don't ask your IT to shut them down every day. Just create a script that does that. There's a service called Azure Automation that can assist you in doing that. A small calculation of how much it will actually save us. If you shut down the machines at 10 a.m., at 10 p.m. every night, turn them on automatically at 7 a.m., and shut them down for the weekend, you'll actually save 50% of the actual running time of those machines. So instead of paying that $40 to $60 per core, you'll pay between 20 and 30. Okay, that's 50% discount for your dev and test machines. That's quite a lot. Second of all, check your instances. A lot of people saying, well, I had an 8-core machine in my production environment, I'll create an 8-core machine in Azure, right? Wrong. I mean, the reason probably you had an 8-core machine in your production environment is because you know the people at IT and you convince them that you need an 8-core machine. Not necessarily you actually need that 8-core machine. Okay? Check your machines that are running currently on premises. There are great tools. This is one of the tools, the IaaS cost estimator. It's a tool that monitors your CPU, your memory, your disk on premises, and then gives you a list showing which types of machines you probably need to use in Azure. You can say if you want machines with more memory or machines with more power, and it will change the suggestion, but basically use tools to understand exactly what types of machines you need. Okay? And if you already created an 8-core machine, just check the monitoring, which hopefully won't cost you $6,000. Check the monitoring to actually see how much CPU you used over the last week. If it's less than 50%, then you probably don't need an 8-core machine, you probably need a 4-core machine. Okay? Next, storage account. There are actually several types of storage accounts. How many people here know which storage account type they are using? How many people here use Go replicated storage account? No? Local replicated storage account? No? You actually, sometimes we don't even know which type of storage account we're using. We just created that, or IT created that for us, and we're using it. There's actually a large difference in the pricing of those storage accounts. A locally redundant storage account stores 3 copies of your data in the storage account. It costs half of a geo-redundant storage account, which basically takes that 3 copies of data and stores another set of 3 copies in a different data center. This is, of course, to manage a situation where, I don't know, there's a meteor strike and the data center is destroyed. Okay? Usually there should be some kind of a really catastrophic failure that will cause all of your free instances of data to be deleted. So figure out if you do want to pay twice the amount of that just to have your data being also stored in a different account, or maybe just use a zone redundant storage, which doesn't cost a whole lot more. A zone redundant storage will take those 3 copies and randomly decide if it will be 2 local and 1 remote, or 1 remote and 2 local. Okay? And that will cost you about half the price. So check your storage account type. By the way, the only problem in Azure is you can't change the storage account type. You need to create another storage account of the different type and then copy everything to that. So, it may be a good idea, but it may be hard to implement if you actually want to change your storage account type. Also, as I mentioned before, keep track of your instances. A lot of people try out Azure by creating virtual machines and then shut those virtual machines down or delete them. And if you just, go to the virtual machine in the management portal, there's a tab there called Images and Disks. Go to Disks and see exactly how many of your disks are actually being used in virtual machines and how many of them just stay there because you deleted the VM and didn't delete the VHD file. Okay, when you delete a VM, there's an option: delete the machine, or delete the machine and the disk. If you didn't delete the disk, you're just paying for that VHD being stored in Azure, and you probably won't even use it. Okay, so just go ahead, delete those files. And as I said, check your bill. Okay, some of you may not be able to do that because they're probably hooked up to another account which has the credit card, but ask for the bill from your bosses. I'm sure they will be happy to send it over to you if you'll say you'll try to save the money. Okay, let's talk a bit about how stuff works in Azure. So, unfortunately, none of us knows exactly how Azure works. I assume that if you grab someone from the Azure team, they won't even know how Azure works because Azure has a lot of teams. There's a team for the database, there's a team for storage, there's a team for the compute, for the VMs, for the cloud services. There are a lot of teams in Azure. Everyone knows exactly what happens in their own field, but you'll ask, for example, I don't know, the website team, how Service Bus works. They won't know the answer. Okay? There probably is only one person in Azure that knows how stuff works, and that's the CTO of Azure, Marko Zinovic. I'm actually not even sure if he knows everything there is to know about Azure. I think that in conferences usually just has an earpiece here and people tell him what to say. A group of all the Azure experts from Microsoft, and they tell me, yeah, tell them it works like that, yeah. So how do we get to know everything there is to know about Azure? Well, first of all, you won't be able to learn everything, but you will be able probably to learn the stuff that you're working with. You're working with Service Bus, you're working with storage, you're working with websites. Just go ahead and learn about those stuff. For me as an Azure consultant, I need to learn about everything, and basically that means I know a lot about something, but I never get a chance to learn everything about everything. Okay, just too hard. So how do we do that? First of all, just go ahead and read the basics. For every Azure service there is out there, there is documentation. There's the basic documentation, and sometimes you can even catch the more advanced documentation, the deep dive. Okay? There are also plenty of sessions on Azure in conferences, main conferences, TechEd, which is now called Ignite. All of those conferences are recorded, and you can download the video from Channel 9. So go ahead to Channel 9 and listen to sessions on how the Azure network works, how virtual machine works, the stuff that you actually need to learn about. Okay? And why is that? Because if you don't know how it works, you make mistakes. And I want to talk a bit about those mistakes and how people actually learn from those mistakes. Okay? So first of all, load balancer. How many people know a bit about how the load balancer works? How many people know what the load balancer is? Everyone. You know what a load balancer. You have two servers, you have an incoming request, there's a load balancer that needs to decide which server will handle the request. Now, there is a misconception about the Azure load balancer that people think that it's round robin. Round robin basically means there is an incoming connection, send it over to server number 1, the next one will go to server number 2, next one server number 3, and then cycle back 1, 2, 3, 1, 2, 3. This is usually how, for example, the Windows load balancer works, the network load balancer, NLB, but that's not how Azure load balancer works. If you go and read the documentation, you actually find out that Azure load balancer works by using some kind of a distribution mechanism. It looks at the incoming IP address, the client's IP address. It looks at the client's port. It looks at the IP the client is trying to reach and the port they're trying to reach. And they're looking at whether the client is trying to open a TCP connection or UDP connection. The load balancer takes those 5 parameters and then decide, according to some hash function, which server to provide. So it's not round robin. It may be that a lot of connections will end up having, a lot of connections will end up on server number A, and server number B will serve only 10% of the connections. But optimistically, a hash function distributes the values the same way, so optimistically it should be okay. So at first, people might think that, okay, so maybe the load balancer has some stickiness, right? And we open a browser, the browser opens several connections, so all of the connections from my client will hopefully reach the same server. No, they won't, okay? If you use a browser on the client end, browsers open a bunch of connections, 8, 10 connections sometimes. Several of those connections will hit server A, several of those connections will hit server B, just because they are coming out from different port numbers, okay? So Azure Load Balancer also, it's not, it doesn't have any type of stickiness. So how can you actually configure that? So a lot of people don't know, but you can actually go ahead and configure the load balancer and change the way it distributes the connections. So first of all, this distribution set is known as the 5-tuple distribution. It's client IP, client port, server IP, server port, and type of communication. You can actually change it to a 2-tuple and to a 3-tuple. So you can actually have, for example, just just client IP and destination IP, and it doesn't matter which client you have, they will always reach the same server. Okay, you can have, for example, a tuple that says, well, I look at the outgoing communication of the client and and the outgoing port and the incoming communication and the incoming port, regardless of whether they're using TCP or UDP. So if you have multiple channels using TCP and UDP, they will reach the same server from the same client. Okay, so you can have different sorts of tuples to match your needs. If you have, for example, I don't know, a UDP channel, how many people actually know what a UDP channel is? UDP, unidirectional. You send a message, you don't get an ACK back if the message was received or not. Okay, so for example, it's used a lot with video streaming. You just send frames, and you have another TCP channel to control that frame. Okay, do you want to pause? Do you want to speed up? Do you want to rewind? That sort of things. So you want those two channels to reach the same server, because you don't want one server to respond with frames and another server to control that server. Okay? So that's sort of things that we look for on how to change a load balancer. By the way, a load balancer in different hosting. A lot of people think that the load balancer is the same load balancer for cloud services, for websites, for virtual machines. The load balancer actually works differently for websites. For websites, and that is why that is what people find out eventually. The load balancer for websites does have stickiness. Okay, it actually does that by adding a cookie to the outgoing request of each and every one of the not the request, the response. Each and every one of the response coming out of the website. So the next time the client sends a request with the cookie, the load balancer identifies that cookie and knows exactly which server to send the message to. Okay, so there is a stickiness in websites. By the way, how many people here are using websites to host their web applications? Yeah. So, for example, the default behavior of the load balancer is to actually use stickiness. Now, I don't know in how many architecture courses you've been, but stickiness is considered a bad pattern, right? So probably those of you using websites, check how to disable that stickiness, assuming, of course, your application are scalable and don't require that stickiness. By the way, it's just adding an additional header to every outgoing response saying, please disable the sticky cookie. That will tell the load balancer not to include that cookie. Okay? Just look up Azure website load balancer, disable ARR. ARR is application request routing. It will tell you exactly what to do. Traffic manager. How many people have ever heard of the traffic manager service in Azure? Traffic manager, going once, not twice. Okay, everybody heard about load balancing. Load balancing is just a routing mechanism. Traffic manager is a DNS-based load balancer. What does it mean to have a DNS-based load balancing? Let's do a brief DNS resolution 101. When you enter an address in a website, in a web browser, you enter a DNS name. Okay? DNS, it's client search because the N in DNS name is name, but okay. You enter a DNS address, www.cnn.com. That's a name. To actually access the server where CNN is hosted, the web browser needs to know its IP address. Okay? So we do a process called DNS, DNS lookup, where we send the DNS record www.cnn.com to a special DNS server and get back the IP for cnn.com. So you send it probably to your ISP DNS server. Okay, you automatically get that address in your configuration, and the ISP sends that request to the site that manages CNN.com, and that site responds with, yeah, the IP of www.cnn.com is the following. Now, your machine caches that information for a couple of minutes, just so it won't have to redo this entire process again and again. Okay? After, I don't know, an hour or so, it will do that again and then cache it for another hour. That caching period is called time to live, or TTL. So what is the Traffic Manager service? Traffic Manager allows you to actually take two different applications that you have, They can be in the same data center, they can be in different data centers. Usually we'll put them in different data centers just so we'll have disaster recovery. We'll have the same website in 2 different data centers, North Europe, West Europe, and we'll have traffic manager manage their DNS mapping between address and name. The client will actually browse to myapplication.trafficmanager.windows.net. Traffic manager will respond with the IP of either the deployment in West Europe or the deployment in North Europe. Okay, brilliant. Now what? The idea of Traffic Manager is it also monitors your deployments. If one of your deployments fails, it will shift all the DNS responses to point to the other IP address. Okay, so Traffic Manager is basically a failover mechanism. You'll always use your West European or North European deployment, but if Traffic Manager identifies that that deployment has been degraded, it's not working, it will start responding with the IP of the second deployment. Okay, that's a great service. You can actually even set how much time the client will save that record, the TTL time for those DNS responses. Usually, if you want a fast failover, you'll switch the TTL down to say 1 minute. Okay, and that's great. And we had a customer doing that because they needed to have a quick failover for the application, and they lowered the TTL to 1 minute. They had the deployment in Western and North Europe, and they thought it works, but it didn't work. And then we started to figure out why it's not working. So the first thing that we did is to use special websites that you have on the internet that do DNS testing for you. You enter an address, those websites go to multiple of DNS servers around the world for known ISPs like Verizon, AT&T, that sort of stuff, that sort of companies, and they try to retrieve the DNS record for that address. Hopefully, it will be the same from all over the world. But what we realized is once Traffic Manager switches from data center A to data center B, some of the DNS servers continue to return data center A, but some do switch to data center B. Weird. We opened, of course, a ticket. Microsoft said we checked Traffic Manager, that it works just fine. Check your own end. And then we realized something very strange about how DNS works globally. Most of the companies, most of the ISPs, the big ones, do respect time to live. And after the time to live ends, after that 1 minute, they will re-query the DNS record. But there are a lot of small ISPs around there. Okay, mobile service ISPs, local companies that has their own ISP servers, their own DNS servers, remote continents like Australia that for some reason don't have enough bandwidth to the internet, so they change their DNS rules. And they actually, a lot of the companies don't respect the TTL timing and decide on their own TTL. So for example, you think it will be cached for 1 minute, it will be cached for 1 day. So customers connecting to that ISP won't be able to get to the disaster recovery website for the next 24 hours. That is not what we wanted to see in Traffic Manager. But, you know, there's promises on one hand and reality on the other hand. So what does it mean, know how stuff works? Don't settle with just reading about it. Try it, read about it some more. If those IT people in that company read about DNS propagation and online, they would have found quite fast those complaints people have about their ISPs not refreshing their DNS addresses. Okay? I myself suffered from that on my data plan on my phone. I tried to reach to my online bank account, and I couldn't get to that bank account through my mobile plan data, my data plan on my mobile. Switched to Wi-Fi, it worked. Switched back to my data plan, didn't work. Called my ISP, called my mobile service company, told them that you have a problem with your DNS servers, please refresh. I had to go through some people until I got to tech support, which actually understood what I was saying. Refresh their DNS, it worked. Okay, so do know how stuff works, do try things out. Azure Compute. We have different types of compute and hosting in Azure. Cloud services, websites, VMs. they don't operate the same. Virtual machines have persistent disks. Cloud services have temporary disks. Okay? They work differently. You restart a cloud service, your entire local data might be deleted. If you store local logs on the hard drive, they might be deleted after that machine restarts. Okay? There are different ways to handle virtual machines and cloud services. You have to know how those stuff work. So, for example, you won't get your log files being deleted if your machine crashes. I say that because that's what happened to one of my customers. Okay? There are a lot of best practices to do that. We'll talk about that later on. Incoming, outgoing IP. A lot of companies need to know the IP of their machine, because a lot of companies, when they, for example, they handle credit cards and they need to reach out to special services online that handle credit cards, handle credit card payments, they need to send the request from a specific IP address. Anyone doing credit card management here? No? You have to have a fixed IP address on the internet that your communication is coming out from, just so that a credit card company can identify your originating service call. So a lot of people think that in Azure, when you create an instance, that instance's IP is also the income. Of course, it's the incoming IP, but it's also the outgoing IP. No, it's not. Okay. For virtual machines and cloud services, yeah, that's the case. If you get an IP, I don't know, 192.0.0.5, that's your incoming IP, and that's your outgoing IP. Okay, if you connect to a different server, it will say you came from 192.0.0.5. But if you are using, for example, a website, the website hosting of Azure, you have an incoming IP, but your outgoing IP is one of 4 different IP addresses that you have for that cluster where your website is hosted. You delete that website, you recreate it, it will be recreated in a different cluster of computers. It will have 4 different outgoing IPs. Okay? Know those things, check them. Don't assume the outgoing IP is the same as the incoming. I actually had a client who realized that after deploying the applications to websites, and they had to go back and deploy the application to virtual machines because of it. Okay? Know that before you spend a lot of money just hosting stuff in a place you won't use it. Because basically, by the way, Azure websites cost more than Azure virtual machines. Okay, so how do we learn the stuff? Read blogs. Don't spend time on reading books, because by the time the book is published, it's not relevant anymore in regards to Azure. Okay, stuff are being updated too frequently. Read blogs. There are different blogs from the different Azure teams for the storage account, for storage and Active Directory, and for websites. They all have their own blogs, so just look them up. Check the limitations of different Azure services. There are great articles from Microsoft about it. Let me see how many people here know that there is an Azure user group in London. Were you in the last meeting?
Sorry?
Were you in? No, okay. There is a local Azure user group here in London. Go to it. They offer free beer. Okay? They meet once a month and they talk about Azure. Cool stuff. I happened to talk there about 3 times already while I was visiting here in London. Learn from other people. That's what I'm saying. Okay? Learn from articles. Let's talk a bit about architecture. How much time do we have? Windows Phone. Yeah, okay. So, first of all, why do we use Azure? A lot of us use Azure to just take the virtual machines from their on-premises environment to Azure. That's great. That works almost flawlessly, assuming you haven't done anything complex on premises like creating 10 network cards in your virtual machine. Okay, because usually Azure doesn't support 10 network cards. Originally, it supported only 1 network card per server. Today, they support up to, if I'm not mistaken, 4 network cards per server, depending on the instance size of your server. But just lift and shift. There are great tools to also take, for example, VMware files. How many people are using VMware on premises to virtualize their servers? Okay, so VMware virtual hard drives are not the same format as the virtual hard drive format of Azure, which is a VHD file. So even if you're using Hyper-V, for example, those are VHDX or something like that, which also doesn't match the format of Azure. But there are tools that you can download that perform the conversion between VMware or Hyper-V and the format of Azure, and also upload that file already for you to Azure. Okay, so lift and shift scenario, a lot of people are doing just to start the first steps in Azure, just like an on-premise, but in the cloud. Another stuff people are doing in Azure is dev and test. I have a number of dev machines in Azure because I don't want to install Visual Studio 2015 CTP on my own machine. So I install it in Azure. You can actually get a VM with Visual Studio installed in Azure. Okay, you don't need to actually sit down and wait for 10 minutes to it being installed. There's already an image for that. A lot of people are shifting their testing environment to Azure. Okay, so they start up test servers in Azure, and by the end of the day, they shut them down and then turn them back on at the beginning of the next day. A lot of people, unfortunately not too many people, are moving to Azure to actually use the platform as a service and not only infrastructure as a service. Some people take websites, their own websites, and instead of hosting them locally, host them in Azure websites. Can be websites, can be web applications, can be static or dynamic websites. But some people are also trying to use the Azure services, database as a service, caching as a service. Okay, that's the real big thing about Azure. All of those platform as a service components that you can use instead of doing it yourself, creating a virtual machine and installing Redis cache on it, creating a virtual machine and installing Elasticsearch on it. Okay, instead of doing that manually and then managing all of those VMs, a lot of people are trying to reach out to Azure to use those components as services. And in the last couple of years, of course, the entire field of big data and big compute, the fact that we have the ability to use thousands and tens of thousands of machines in the cloud, assuming you have no limits on your credit card, you can go ahead and harness that entire CPU power to do a lot of calculations. Just, I think it was last night, I watched some TV here and there was a commercial by Microsoft. Have you seen that? That Microsoft, they call it the Microsoft Cloud. They don't mention the word Azure for some reason. The Microsoft Cloud commercial, and there's some professor discussing how they use the Microsoft Cloud to break down the genome, and they are now able to do a lot, 100 genes per day instead of 1 gene during 100 days. Okay, and that's basically the power of the cloud, compute power. So for best practices, as I mentioned before, there are a lot of stuff like how to scale up, how to scale out, how to do disaster recovery, how to use cache in order to store your sessions instead of storing them in memory. There was a great session by Nuno, another speaker here in the conference, back in Tuesday. I'm guessing that session was also recorded. So, after the conference ends, I guess they will upload all the recordings to the website, so just go ahead and watch that recording. I wasn't there, but I guess it was cool. But I want to talk about how we actually implemented some of those things, and not implemented, but how we, well, for lack of a better word, how we suffered from some of those features and how we overcame those problems. So, first thing that we had are issues with customers not being able to access their instances. For example, they had Traffic Manager, and Traffic Manager suddenly reported that their server is offline, but it wasn't. Customers reporting that the load balancer, for some reason, can't access some of those servers. All of their traffic is directed to 2-3 servers in the load balancing set and not for the other ones. Customers complaining about trying to use external tools to Azure that check the website for timeouts, okay, check for the availability. Tools like Pingdom. Anyone using Pingdom? Pingdom? No? It's an online website that you can give it the addresses of your website and we'll just check if they're online or not. It will ping them, not ping, but send an HTTP request every couple of seconds, check the response time, check the content, and will inform you by text messages, emails, if your website is offline or online. Okay? Probably not online because that will be too many emails per day, but so we try to do some troubleshooting with those customers. First of all, of course, first thing that you do, open a ticket with Microsoft support. We open a ticket, they asked us to collect log files, we looked at the servers. Unfortunately, IT neglected to turn on the flag that says create log files, so we didn't have any IIS logs. For those servers that we did turn on IIS logs, there were cloud services, and by the time we got to check the problem, the developer was in charge of that cloud service, already deployed a new version, and when you deploy a new version, sometimes the machine needs to restart, so it restarted and the logs were gone. We asked Microsoft support to check the logs for Traffic Manager and Load Balancer. Apparently there are no logs for Load Balancer, only for Traffic Manager. So they were able to tell us, well, Traffic Manager got a timeout when it sent a request to your server. Okay. They also told us that without IIS logs they can't do much, so we went on and turned on IIS logs, but not just turned on. As I mentioned before, for cloud services, for example, these logs will be deleted if the machine restarts. So we also turned on the Azure Diagnostics plugin, which grabs those IIS logs in addition to all sorts of logs, event viewer, application logs, dump files, and uploads them periodically to Azure storage. Okay? So we use those, and once we had the entire set of information, we actually found out that it wasn't Azure's problem, it was our problem. The website had a lot of load while those tests were happening, while Traffic Manager monitored the website, and basically we were not able to produce a response in the required time limit. So, for example, Azure Traffic Manager waits for a couple of seconds to see if the health check worked, and the health check that we did, the customer did, was actually involving the database, not just returning, I'm online. Let's go to the database, check that the data is there, that the tables are there, and then returning a response that everything is okay. And that process took a lot of time when the entire environment was under load. So it took a lot of time, we didn't respond correctly, and Traffic Manager just disconnected our website. And that's a problem. We only identified it after IT turned on the logs. So, conclusions. Turn on logs. Don't count on Azure to monitor your systems, okay? Because they're not your IT. They're just some global IT that makes sure everything works. Also, another one of the things, VM endpoints. When you create an endpoint for a virtual machine, endpoint is that public port that is open to the internet, you have the option to specify an ACL for it, an access control list, which IPs from the internet can actually communicate with that endpoint. Okay, usually it means that you want your on-premise environment or a specific enterprise to communicate with that service, so you block everyone else. Traffic Manager is also part of that everyone else. Okay, so don't block Traffic Manager. You can actually get the Traffic Manager IP ranges if you check online for documentation. The links at the bottom are to how to use the cloud service diagnostics. By the way, that same plugin that you had for years for cloud services, cloud service diagnostics was in Azure ever since Azure became Azure, which is back in 2009. It's also available today for virtual machines. So you don't have to go over all of your virtual machines and manually collect IIS logs and that sort of stuff. It's available, you can install it, and it will just collect that data and put it in storage for you. Okay? Making developers happy. Are you happy using Azure? Come on, say the truth, although you are recorded. Yeah. It depends on the day. A lot of the complaints that we had from people using Azure was from people using cloud services. Anyone here using cloud services? Cloud services? Yeah? How much time does it take to deploy to a cloud service? Didn't do it yet. Okay. So from our experience, and it's not because of the slow internet connection in Israel, deploying to a cloud service can take deploying. I'm saying you compile your code, you saw that it was running, you want to deploy to a server and test it online. Takes about 7 to 10 minutes. Okay? On a good day. Many developers are just fed up with the time that it takes to upload those stuff. So why is that? That's because basically cloud service deployments work differently than, say, a website. A website is an incremental update. A cloud service is an entire package deployment. Okay, the server is restarted, the package is being deployed to the server, the entire package. Basically, it's a platform as a service solution that can handle an infinite scale of servers, so it can just get another server, take your package, and the application will start running on a new instance just by a click of a thumb. Okay, so it takes a lot of time to do that. In addition, there are some services that are installed in every one of those instances that may affect the load time and the stop time of those cloud services. I'll get to that just in the next slide. So what can we do? First of all, if you can, please use the compute emulator. If you install the Azure SDK, it ships with a compute emulator that you can mimic a worker role on your own machine, mimic a web role on your own machine. It works quite well, and try to use that instead of just deploying to Azure every time you compile your code. Next, if you have a slow internet connection, I don't know if you suffer from such things in the UK, but we have those in Israel, companies that have slow internet connection. My recommendation, always create a virtual machine in Azure in the same data center as your deployments. Install Visual Studio there, hook it up to your Git, to your TFS, to your Visual Studio Online, grab those bits, compile them, and deploy them through the virtual machine. Uploading 100 megabytes through a virtual machine will take probably 2-3 seconds instead of a couple of minutes from your own premises network. Okay? Just try to do that, and you can always shut the machine down at the end of the day and save money. It doesn't necessarily have to be a really huge machine. It can have 2 cores, just for the compilation. Okay? If you're using web roles and you're using development environments where you have only one instance of the web role, you can actually check a checkbox in Visual Studio that says use web deploy for that web role. Difference between web deploy and a deployment package: web deploy is how websites work. It will only deploy the new files which were added or changed. So web deploy, it will take about a second or two to deploy an updated website instead of 10 minutes. Okay. Lastly, don't be afraid to turn on remote desktop and just use that machine as a server that is on premises. RDP to that machine, copy files to it, delete existing DLLs, replace with your DLLs, stop the service and start it again. It works, and it reduces the amount of time of redeploying from 10 minutes to 10 seconds. Okay? Don't hesitate to do that. It's okay. It's not a production machine, and there's a blog post describing exactly how to do that. And lastly, as I mentioned, there are some things inside a worker role in the web role that may affect the start and shutdown time. Mainly, that thing that is called in-role cache. Don't use Azure in-role cache. It's also a recommendation for Microsoft lately. They're discouraging people from using the in-role cache and instead telling people, please use Redis as a cache, that cache service that is available in Azure. Simply because the in-role cache takes a lot of time to start and to stop. It sometimes hangs because it has difficulties getting the stuff that it needs from Azure storage. It's a problematic service when you run it in a web role and a worker role. So don't use it. Okay, my recommendation to you, not as a Microsoft evangelist. Data synchronization. In case you want to have a disaster recovery site, then you'll have to do 2 things. First of all, you have to make sure your application is also deployed to the second data center. That's usually not a problem. We can deploy it to one data center, deploy the code, and then deploy the same code to the second data center, right? That's not an issue. The issue is managing the data replication. The SQL data replication, the blob storage, table storage, that whole storage stuff from Azure, we need to replicate everything between the two data centers, because the fact that an instance is not working in one data center might also imply that the storage won't work in that data center. So we don't want the other instance from the other data center contacting the database on a data center that might be down. So what solutions do we have for that? First of all, for database synchronization, how many people here are using SQL Server, for example, on a VM in Azure? Okay, so for you people, if you're using SQL Server 2014, that has the always on feature. Always on now supports replicating between data centers. So that's a really good feature to replicate your data. If you're using MySQL, that also has the capability of doing master-to-master synchronization. Basically, most databases, even the SQL database service from Azure, has the ability to do some kind of a geo-replication. All the databases support that because all the databases support replication in some way. The difficulty is having that replication be between data centers and because of the latency of the network. Okay? But usually there are solutions for that. The problem starts with the storage stuff, Azure Tables, Azure Blobs. So for Azure Tables, what we recommend to our clients, if you do want a DR site and you're using Azure Tables, don't write directly to those tables. Instead, use the transactional data pattern where you actually write the content to a queue and then have a worker role. Grab that information from the queue and write to table storage. That way you can basically just write your content to one queue or to two separate queues in two different data centers and have two different worker roles pulling that information and updating two different table storages at the same time. You can even use transactions because Azure queues, not the storage queues, but the service bus queues, support the concept of session, where you can send multiple messages using a session ID, and that basically means a transaction. Okay, so a worker role can pull several messages that are part of a transaction and then choose to commit at the end of that transaction. So there is some information here on how to use that pattern. For blobs and files, that pattern is less suitable because we won't, store blobs in a queue just to have them replicated to two different data centers. For blobs and for Azure files, how many people are using Azure files? Azure files? It's in preview, so I understand if you're not using it. For blobs and Azure files, you'll probably have to, unfortunately, do it yourself. Create some replication code that grabs blob storage files and copies them to a different location. There aren't any good third-party tools that I saw, unless someone can give me a good name of a company that does that. But you do have some stuff to help you, such as the WebJobs SDK that has a listener for blob storage that can just invoke a method that you have whenever there's a new blob in the container. That works quite well, at least until you have 4 million items inside the container. Beware of that. Okay, we tried to check that once and it didn't work quite well. Okay, so beware of huge containers. Services in Azure. I don't know how many of you, let's see with a raise of hands. How many people tried to access Azure storage and got an exception, a timeout exception? Anyone? At least I had a little tackle with that. How many people tried to access SQL database as a service and got their connection being disconnected due to timeout or dropped or had a throttling message coming up? Okay, so some of you. There are things in Azure that you should understand. The services in Azure, underneath the hood, use instances, use database, use storage. Service bus, for example, is both machines using code, running code, and databases storing a lot of information that you have in regards to your service bus account. Okay? If there are many users using them, there might be some network congestion sometimes. There might be heavy CPU loads on those instances. Stuff can happen. Or to be correct, stuff will happen. Okay, maybe not twice a day, maybe not twice a month. Hopefully not twice a month, because that's the situation right now. But it will happen. So how do you protect yourself from service problems. First of all, do retries. You weren't able to write to the storage account, retry again after a second. Okay? There is built-in mechanism in the Azure Storage SDK to do that. It's called retry policies. There's also a built-in mechanism for that in the Service Bus SDK. There's also built-in mechanisms for that in Entity Framework if you're using Entity Framework for databases. Okay? Just apply best practices for what is known as fault tolerance. There's also an application block for Enterprise Library to handle that situation. Basically, it's just a function that gets a lambda and tries to invoke the lambda again and again until it succeeds, or until some kind of a timer goes off. Use failovers and backups. So for example, if you're using storage, you can actually use read-only geo-replicated storage that allows you to read a copy from the geo-replicated location. If you're using Service Bus has a special mechanism. The SDK has a special mechanism called secondary namespace. When your client isn't able to send a message to the primary namespace, it will automatically send a message to the secondary namespace, and your consumer, using that same SDK, will be able to read from that secondary namespace for you. So you'll have the first one in your main data center, the secondary in another data center just in case. Okay? There are stuff for that. Go ahead and read about those stuff. Remember, know how stuff works. Making things faster. Let's speed up a bit. So a lot of people complain, at least to me, that Azure is slow. It's not that slow. It may have some issues in comparison to AWS, for example, but the idea is know what you're doing. A lot of people are using the Azure Storage SDK and they're complaining, I'm getting 50 to 60 milliseconds latency when I'm sending stuff to Azure Blob Storage. Well, have you checked what the SDK actually does? Maybe you can improve the defaults, such as using concurrent uploads, such as, I don't know, moving from HTTPS to HTTP, stuff that can actually reduce the amount of time it takes to create a channel and to close the channel, stuff like that, reusing channels. A lot of people don't look at the SDK other than just, which method they need to invoke. So it is, in fact, a reality that Azure services are not as fast as your on-premises network. I mean, writing a file to Azure Storage will never be like writing a file to a hard drive in some NAS storage in your on-premises environment, because it has 3 different applications, it has a logging mechanism, it does a lot of stuff. So what can you do? So first of all, try to understand exactly what you're dealing with. Get a baseline. See that if it actually takes 4 milliseconds or 15 milliseconds for one file. Okay, just get the understanding of how it works. Then try to do some benchmarking if you want. For example, if you're using cache as a service like Redis, there are benchmarking tools that will tell you exactly how many requests per second that service can handle. If you want, you can compare that to, for example, having Redis on a VM. We actually did that and it's quite the same. There's not much of a difference. But bottom line, investigate. Try to learn how stuff works. I keep repeating that. Some examples. Azure Storage. How many people are using .NET? .NET? Okay, many. So for example, .NET is not configured that well to use HTTP with storage. So for example, there is something called expect 100. When you send a request to a server, you first send only the headers. That's how .NET does it. It sends the headers, and then it waits for a response from the server saying 100 continue. Saying, okay, I got the headers, it's okay, keep sending the body. Now, if you don't get, if your client doesn't get the response back, that 100 continue, it will wait for a couple of hundreds of milliseconds and then send the request. Not 100, maybe 15 or 50 milliseconds, something like that. Storage accounts don't respond with 100 continue. So if you're using stuff like blob storage, table storage, you're basically sending a request and you're waiting for nothing to happen. Okay? Because your client will just wait for a couple of milliseconds and then send the body. You can turn this off. It's a simple property in .NET. Expect 100, look it up. You can just set it to false and it will automatically send the header and the body. Okay? In addition, nagling. Nagling is a feature that tries to reduce the amount of packets being sent on a TCP channel. So it will try to wait for an abundant amount of data that it needs to send to an endpoint. And if that means waiting a couple of milliseconds before sending a small packet, it will wait. If you use table storage, for example, where a simple request for a GET is no more than a couple of hundreds of bytes, and usually a packet is about 1.5K, you will actually wait, again, for no reason. Okay, disable nagling, it will send the request immediately without waiting for some other data to come in. Those tips, by the way, are not things that I came up with after looking at the .NET code. These are known best practices on how to use storage accounts. Okay, and it's listed on the Azure website. Again, getting back to read all there is to know about it. For Service Bus, there are also stuff you can do. You can reuse clients, you can reuse the Service Bus factories, you can batch messages and send them in one request, you can prefetch a group of messages and handle them one after the other in memory. Okay? All of that information also is documented online. I saw a lot of people not implementing those best practices and then complaining that they are only able to pull 10 messages a second from Service Bus. After they applied those best practices, they were able to pull about 100, sometimes even 200 messages from Service Bus in a second. Databases, you can also improve databases. So for example, if you have a virtual machine running a database, you can actually increase the speed of your database by striping the hard drive together to one virtual hard drive and increasing your hard drive's IOPS, your I/O operations per second. You can increase the performance of your SQL database as a service by using, for example, ActiveGeo replication. ActiveGeo replication is provided in the premium tier. It allows you to store data in one database. That data is automatically replicated to a secondary database, and you can actually do all your reads from the secondary database. So you actually have one database for writing, one database for reading, and that spreads the load. Okay? So there are many performance improvements that you can apply. You just need to go out and read all there is to know about it. Before I conclude, I just want to talk about preview features. Anyone using any preview features of Azure? Azure Files, Data Factory, that sort of stuff? No? Okay. Well, first thing, of course, don't use them for production. It's in preview. Just like you won't compile your code and deploy it to a server when you're using, I don't know, .NET 4.6, which is in beta. Why not? Because it has bugs. No documentation, so it will take you a lot of time to learn about it. There's no warranty of how it works, if it works well or not. Sorry. I have 20 minutes here. You don't know if it works well or not. There is no SLA for that, so if it shuts down for an hour, that's not Microsoft's fault, okay? Because you're using something that is in preview. There is always the possibility of breaking changes, and I have a lot of bad experience with breaking changes in preview versions, but that's just the way it is. And the most important thing is you don't have any Azure support for those features. So if you stumble upon an issue, you don't have anyone to go to other than the forums. Okay? Hopefully, the Azure team that manages that product is listening to the forums. So why do try that? So first of all, when you use a preview feature, the Azure team is a lot more attuned to your needs. If you have a specific business requirement, it's probably best that you present it during preview and not after it's in GA, in global availability. Because during preview, there's a good chance that the product manager will listen to your needs and maybe even add that feature into the release. I can tell you a story. For example, I'm using Azure Data Factory. Azure Data Factory is an ETL product, stuff that takes data from one place, processes it, and places it in a different place. Extract, transform, load. And we're working with Data Factory on the client side, and we're trying to do some stuff, and we're getting a weird message, okay? Something not supported. I reached out to the product manager, they helped me figure out why it's not working, and then they asked me a simple question. Can you please explain your scenario? We're interested to know if we need to support that or not. Okay? They do want to know why we use those features and how they can improve those features. It will also eventually save you money. A lot of the services that you have in Azure costs less than creating them as virtual machines. Azure Search will cost you a whole lot less than creating Linux virtual machines and installing Elasticsearch on them. Okay, by the way, Azure Search uses Elasticsearch. Azure Redis as a cache, it will cost you less than creating a virtual machine, either Linux or Windows, and installing Redis on top of it. Of course, not mentioning what will happen when you want to have high availability and you want to install several of these servers. Okay? So eventually it will save money. No reason why not to try it even before it's in release, just to understand how it works. Okay? And notice the bugs. Some of these features, some of these preview features also cost less during preview. Sometimes it will be for free. Sometimes it will be about 50% discount. So if you can use that discount, when you're testing stuff for dev, for test before production, why pay for a virtual machine the full price when you can get it as a preview for a reduced cost and for a reduced price during preview. Sorry. Okay, so do try these things. So how do you find out about all these preview features? First of all, there were announcements, like the one that was this week. There is a list of preview features that you can see and enlist yourself to that preview feature. Usually they accept everyone who wants to try it out. There are forums for each and every one of the preview features, so just go ahead and ask the questions there. Read everything there is to know about features when it comes to external APIs. I see it happening not only for preview features, but also for production features, for stuff that's in release. In the management portal, you sometimes have about 70 to 80% of the actual configuration you can do with that feature. How many people ever heard of the feature in Azure called API management? API management? Yeah. So API management, basically, it's a service wrapper. You create your own web services with web API or whatever. This is a routing mechanism that gets a request and pushes them to your API services. But that routing mechanism is smart. It can do authentication. It can do not billing, but it can do subscriptions and access limitations. It can do a whole lot of things for you instead of you implementing it on your own in your own services. That feature has about 50% of its configuration only in PowerShell and not in the management portal itself. If I didn't read the documentation, the detailed documentation about that service, I wouldn't have known that I have a whole lot set of configuration features in command line and not only in the management portal. Okay? And one of the most important things, at least as I see them, hook up with leading personnel from the community that will help you implement those preview features. People like Azure MVPs. You have a bunch of them here in the UK. Some of them even live here in London and nearby. Azure insiders, okay, people who can actually reach out to the product managers and ask them how stuff works, to reach out to the teams and report bugs. Or in my case, report a bug and they told me they don't know when they'll get a chance to fix it. Okay, that also happens. But at least now they know that there is a bug. So reach out to those MVPs, to those insiders. They didn't get that title for no reason. Okay, they need to help you. Otherwise, they won't get renewed. Lastly, tools. So first of all, a great tool to manage virtual machines, cloud services, storage accounts, a tool called Azure Management Studio. It's by a company called Cerebrata, who is now owned by Redgate. This tool allows you to create, configure all of your environments in Azure. In addition, it also shows you all the diagnostics of your machines that you collected into storage. It pulls that data and shows it to you in a user-friendly in a user-friendly interface. For virtual machines, you have a tool called IaaS Management Studio. That tool is similar to the Azure Management Studio, but it's only for virtual machines, but it gives you a full description of your virtual machines, which disks do you have attached to those virtual machines, the ports that are open. Really easy tool for configuring and creating new virtual machines. Service Bus Explorer, a really great tool to manage your service bus namespaces, hook up listeners to queues and topics and event hubs, send test data into those queues just to test them out, manage the configuration, manage the credentials of users through that tool. It's a very cool tool, open source. You can actually download the code and compile it. It's written in C#. For storage, there are plenty of tools for storage. Unfortunately, there are almost no tools for my Mac. So I'm using, for example, CyberDuck, which is an FTP tool, but it's also able to show files from blob storage. How many people here don't use Windows? Only me? Okay. For those listening, okay, out there in the recording, if you're using other platforms than Windows, you also have a great website called Zudio. Zudio is a website that allows you to manage storage accounts through that website. So assuming you're willing to provide that website with your storage credentials, it will show you everything there is to know about your storage accounts and allow you to manage stuff like blobs, tables, queues from the web. So you can do it on a laptop, on a tablet, on your phone. Okay. Other great tools, Cloudberry Explorer. It has a free version and a paid version. That's only for blobs. Cloud Explorer and Azure Storage Explorer also for tables and queues. Best thing about Cloud Explorer is that using a single UI, you can manage both Amazon and Azure storage. Okay, so blob storage, S3 storage, and that sort of stuff. For command lines, of course, you have the PowerShell command lines. How many people are using PowerShell to manage their Azure subscriptions? Check out those PowerShell command lines. They actually allow you to do more than the stuff that you can do in the management portal itself. Okay, about 80% is in the portal. The rest of the 20% is in the PowerShell. There were actually features that were released in PowerShell and only after 4 months got released in the portal. Okay, so look it up. In addition, if you're not using Windows, there's also the Azure CLI, command line interface tools built on top of Node. So they run on Windows, on Mac, on Linux, wherever you can run JavaScript. There are also APIs that you can use. Basically, all the Azure management is HTTP based. The PowerShell, the CLI, everything uses that HTTP services. So there is a tool, for example, how many people are familiar with LinkPad? LinkPad, a tool for .NET. So you can actually use that tool in conjunction with a link to Azure tool that allows you to write SQL queries on Azure. Select asterisk from VMs, where VM.name starts with something. And it will just create that query and will send it to Azure. There is also an SDK for .NET, so if you want to create your own management application, to create virtual machines, to create cloud services, to query stuff, to put it on a grid, you can also use an SDK that gives you a virtual machine class, a cloud service class, a subscription class that you can use it in your own code. So to conclude, having a cloud mindset is a required, I don't know how to call it. Let's rephrase it. It's important to have a cloud mindset when you're starting to use Azure. It's important to architect for the cloud, but you can't architect for the cloud if you're not familiar enough with that specific cloud. Okay, don't architect for any cloud. It will just give you an application that doesn't perform well. Look up stuff on how Azure works. Go and read articles. Go and consult. Go and check out new preview features. Okay, it's really important to keep up with the pace. Otherwise, you'll end up in a couple of years, like I had with a couple of customers, that I came to consult them on Azure, and they're saying, yeah, we're thinking of going to Azure, but the last time we checked Azure, they didn't have any virtual machines, so we can't use it. But there are virtual machines ever since 2012. Oh, we didn't know that. Can you show that to us? So keep up with the pace, otherwise you'll end up thinking that Azure works like back in 2010 in 5 years. So just regarding resources, there were a bunch of links during the slides. I didn't see everyone taking pictures, and that's okay. This is the only link that you will need to get all of those slides that you just saw, and all of the links are there. And my contact information is also there. If you want, just tweet me, ask me questions. I'll be more than happy to answer. And since you came here and you're not hearing this recording afterward, there are a bunch of Azure giveaways here, posters, glass wipers, stickers and such. You can just grab them on your way out. So thank you very much for coming. Have a great rest of the day. And if there are any questions, I'm here. Thank you.